Assalamualaikum and hello everyone. Welcome to our video presentation. Today, we will present our case study on projectile motion for the introduction to mechanic MAT 272. Before we begin our presentation, let it So, what exactly is projectile motion? Now, let us explain the introduction to you. Projectile motion is the motion of an object that is launched into the air and angle and move under the influence of gravity. As the object travels through the air, it follows a curved path known as a parabolic trajectory. This motion consists of two components. The first is horizontal motion, which remains constant, and the second is vertical motion, which is affected by gravity. We can observe projectile motion in many sports such as netball, basketball, football, and volleyball. In our case study, we will focus on netball to explain how projectile motion helps players make a more accurate shot. Now, let's move on to important terms used in the projectile motion. There are four important terms that we need to understand before solving any projectile motion problem. The first term is initial velocity, represented by u, is referred to the speed of the ball at the moment it is released. The second term is launch angle, represented by theta. This is the angle at which the ball is thrown. Next is gravity, represented by g. Gravity is the force that pulls the ball downward through its motion. Lastly, we have a time of flight, represented by t. This is the total time the ball stay in the air before reaching the target or landing. These four terms are really important because they help us analyze and calculate the motion of the ball accurately. Now that we know these four tips, how do we apply them in a real situation? Enough with the story. Let's put this concept into the practice to our neighbor case study. Well, compare shots from 1 meter, 2 meters, and 3 meters.
I always miss my shot. I'm so frustrated and give up.
Ugh, same here. Sometimes my shot goes in, but sometimes it flew over the ring. It's so annoying. I think mechanic can help. It's called projectile motion.
Projectile motion? What's that? I never had that.
It's the ball when we throw forward while the gravity pulls it down. It makes a curved path. Whoa, like a rainbow curve? Exactly. To get a good shot, you need the right angle and the right throwing force.
What's the best angle for the best shot?
Around 55 degrees to 65 degrees can help the ball go into the hoop smoothly. Oh, no wonder why I always miss my shot when I throw too straight. Yes, it is. If you throw it too low or too hard, it's harder for you to score.
It's really work. I don't believe that.
Let's find out. Good, let's try.
Let's go!
So, from our video, let's observe the three shots carefully. For the first shot from 1 meter, the ball enters the hoop easily because the distance is short. The player used a launch angle of 58 degrees and only a small amount of force is needed. For the second shot from 2 meters, the launch angle changed to 48 degrees. Since the distance is greater, the player needs a slightly stronger throw to keep the ball on the correct trajectory. Finally, for the 3-meter shot, the launch angle is 42 degrees. Although the angle is lower, the player must apply greater initial velocity so the ball can travel farther and reach the hoop. Even though the shooting distance and launch angle are different, all three shots still follow the same principle of projectile motion. Next, we will calculate each shot using the projectile motion equation.
For this part, I will explain our calculation for projectile motion in netball shooting. First, we identify the information given, which is G equals to 9.8 meter per second squared. Second, height of the hoop equals to 3 meter. And lastly, release of height. We assume that it is 1.8 meter. So, the vertical displacement is Sy equals to 3 minus 1.8 equals to 1.2 meter. Next, we use the projectile motion equation to find the initial velocity, which is Sy equals to x tangent theta minus with gx squared per 2u squared cos 2 theta. Means u equals to third gx squared per 2 cos squared theta x tangent theta minus sy. Okay, so now we are going to calculate the maximum height, the time of flight, and lastly, the horizontal range for 1 meter at 58 degrees. Here, we need to use the formula that we already did above. So, the final answer, you will get U equals to 6.61 meter per second. Then, we calculate the maximum height reached by the ball, which is H. And this is full calculation. And the final answer is H equal to 3.40 meter. Next, we calculate the time of flight, which is the total time the ball stays in the air. Using the right formula, you will get T equals to 0.29 seconds. This means the ball takes approximately 0.29 seconds to travel from the player's hand to the hoop. Finally, the horizontal range is the horizontal distance traveled by the ball. And the final answer is R equals to 1. The same calculation is then repeated for the 2 meter at 48 degree and 3 meter at 42 degree. This is the full calculation for maximum height, time of flight, and horizontal range for 2 meter. I like to apologize here because I accidentally wrote the wrong values. It's actually R equals to 2, not R equals to 1. And this is full calculation for 3 meter at 42 degrees. And again, the final answer is r equals to 3, not r equals to 1. By comparing the results, we can see that as the shooting distance increases, the player needs to adjust the launch angle and the initial velocity to ensure the ball follows the correct projectile path and enters the hoop successfully. As shown in the table, each shooting distance produces different projectile motion characteristics. For the 1 meter shot, the ball reached the highest maximum height of 3.61 meters and has the shortest time of flight, which is 0.29 seconds. Since the player is closest to the hoop, the ball requires only short travel distance. Next, for the 2 meter shot, the maximum height decreased to 3.01 meters, while the time of flight increased to 0.46 seconds. This shows that the ball stays in the air longer as the shooting distance increases. And lastly, for the 3 meter shot, the player needs the highest initial velocity of 7.30 meters per second. The ball remains in the air for the longest time, which is 0.55 seconds, and travels the greatest horizontal distance of 3 meters.
In conclusion, projectile motion plays an important role in improving the accuracy of a netball shot. Through our case study, we learned that factors as a launch angle, initial velocity, and gravity all affect the ball trajectory. As the shooting distance increases, the player needs to adjust the throwing force and angle to ensure the ball reaches the hoop successfully. This shows how physics can be applied in real-life sports to improve performance and achieve more accurate shots. Thank you.
Aku jom nak masuk. Go baby go.